Vectors describe the movement from one point to another. So in this case, from our point A to our point B. And this means that not only do we know how far these 2 points are away from each other, but that we've been moving from A to B and not from B to A. So they have a magnitude, a size, and also a direction, and that's what makes them unique and special. So we can describe this vector in a lot of different ways, and these are notations that you might see in your exams. The first one is that we say we're going from A to B. So we have the point A, the point B, and then an arrow as to which way we're going. And that's normally described on a diagram by an arrow on the line. We could also have a name for this vector. So if we had a line, we might have seen it labelled as an A with a bar on the top. It could have been a bold A. Occasionally it's an A with an underline, but not always. And finally, it could be described as a column vector, which actually gives us the values. So it's not just a notation, but gives us the size of this vector. And in this case, that would be 4, 3. 4 along and 3 up. And because we're heading right, and then we're heading up, we've got positive values. If we'd been heading left, and then down, we'd have had negative ones, so that would have been -4, -3. So a vector, a column vector, is first how much along you've gone, and then how much up you've gone. Once we know the information about our vector, we can do all sorts of things. And the first thing we can do is we can have any number of our vector, and that just ends up being a multiplication. And we call this a scalar product. So here we have our vector A hat, or AB. If I said I want 2 lots of A, what I'd need to do is double AB, or A hat. So we've got A here, and we can have A again. And what we're left with, this whole vector now, not just the first bit, but the whole vector, because we've got 2 lots of A there, that's 2A hat. And we could do 3 lots, we could do half a lot, we could do 7 lots, it doesn't matter, but we're extending it in the same direction, we're just extending the magnitude, so we're multiplying it by a scalar, by a number. As a column vector then, if our A is 4, 3, then 2A is 2 lots of 4, 3. So if you think about it actually on a graph, we were going 4 along and then 3 up. Now we're going 4 along, 4 more along, and an additional 3 up. So what we have to do is multiply each part of our column vector by 2. So if A hat was 4, 3, then 2A is 8, 6. Now if the arrow was the opposite way around, so in the previous slide our arrow was facing in that direction, this time it's facing from B to A, we now know that that's precisely what we're doing. We're going from B to A. So this is a slightly different vector, except it's still got the same steepness. It still looks the same. The only difference is that we're going in the opposite direction. So we might still have this vector labelled A, but it's going to be slightly different. It's actually going to be minus A. Because if A was where we were going from A to B, then we're actually just doing it backwards. We're just going backwards, so we're going to be minus A. And our column vector this time then is going to be down 3 and left 4. So -4, -3, because don't forget we always put the horizontal movement first and then the vertical movement. And so we can actually see that we were right to say that it was minus A, because our original A was 3 as a column vector, and this one's -4, -3. So everything's just been minused. It's just negative of what it was before. So if we have the same vector, but with the opposite direction, we must have the opposite sign. So now let's think about adding vectors. So we've got the vector PQ, which is 2, 3, and then the vector QR, which is 2 minus 2. Now if we're looking just at the column vectors, all we have to do is add the top numbers and then add the bottom numbers. So our vector would end up looking something a little bit like this. We're going to do PQ and then we're going to add QR. So PQ plus QR is 2, 3 plus 2 minus 2. So 2 plus 2 is 4. 3 plus minus 2 is 3 minus 2, which is 1. So it's great, we've got the column vector, but what does that look like as one of these? What have we done? Well, we've gone from P via Q to R. We've gone from P to R. So actually, this 4, 1, that describes the vector PR. And that's all adding vectors is. We're looking for that missing side, or the straight line between our first point and our last point. And of course we can add more than 2 vectors together, so we could have had 3, 4, 5, 6 vectors, and we're looking for the straight line between the first point, in this case P, and the last point R.